Good afternoon, everyone. Thank you for joining us for the first installment of the CxEnergy virtual experience presented by the ABC Commissioning Group, as well as its sister organizations, the Associated Air Balance Council and the Energy Management Association. I'm Ray Burt, Executive Director of both ACG and AABC. We were, of course, disappointed that CxEnergy couldn't be held in person this year, but our goal now is to bring you as much of the commissioning, energy management, and testing related education as we can through a combination of these live webinars as well as some additional pre-recorded sessions. A few quick notes before we get started that will apply to this webinar and future ones. We encourage you to submit questions at any time to our presenters using the Questions tab on the left side of your screen. A few will be selected to answer, time permitting, at the end of the webinar, and the speakers have committed to answering the rest via email afterward. On the left-hand side of the screen, you'll see the Resources tab, where you can download a PDF version of the presentation for today's session. There's also a Notes tab on the right-hand side of the screen, where you can make notes on today's webinar that will be emailed to you automatically at the end of the presentation. If you have technical problems during the webinar, click on the Request Support button in the lower left of the player. And then finally, in terms of continuing education credit, you will receive an email after the webinar with instructions on how to get your proof of attendance. We're going to be relying on the CxEnergy app to automate that process. So kicking off the virtual experience today is Commissioning for Reliability and Resiliency, Lessons Learned, with your speakers Bob Knoedler of Hanson Consulting Services and Jim Magee of Facility Commissioning Group. Resiliency seemed like a good notion, both literally and figuratively, for these times we're now in. That's all I have for you. Thank you again for joining us this afternoon, and I will leave you in the capable hands of Bob and Jim.
Thank you, Ray, and welcome everyone to today's webinar discussing reliability, resiliency, and lessons learned. This presentation is copyrighted by ACG and EMA with images either by the authors or through public domain courtesy of Unsplash. Today's presentation will discuss the importance of considering resiliency, reliability, and redundancy as part of an owner's or a community's risk management plans, and both the design teams and commissioning providers' roles in assisting the team in developing the plan and verifying its implementation. We've included a wide variety of examples and lessons learned, as well as typical metrics used in resiliency. When we developed these learning objectives last year, we really had no idea that the first word, expose, would prove to be so prophetic given the current pandemic situation. However, we were well aware that the variety of hazards, threats, and vulnerabilities present in today's society were playing an important role in how corporations and owners approach their management of risk. First, we'll take a look at the variety of hazards and threats facing communities, companies, owners, and individuals today, including how these have expanded and often appear to be accelerating both in number and duration. Then we'll look briefly at commissioning and design attributes and how they can play a role in developing and evaluating resiliency criteria and metrics. And finally, we'll explore a number of various industries and examples with specific threats and vulnerabilities and how they are currently being met. Well, Jim, we thought we'd be in San Diego this month, but I've been spending a lot of time at home.
Well, this ain't San Diego, Bob, but you know, I'm healthy, I'm working, and I'm thankful for it. And I hope you're well too, Bob.
I'm fine, Jim. I'm fine.
I didn't expect we'd live through, you know, these examples of resiliency or more or less the lack thereof, but we are where we are, and I'm really looking forward to the presentation because so much of what we're talking about had natural connections with the current situation.
Exactly. You know, we've all seen or possibly experienced, including this COVID-19, the results of various threats, disasters, attacks, or even tragic events. You know, whether a force of nature, intentional or accidental, they often strike with little or no warning, threatening facilities, infrastructure, transportation, commerce, and or human life. Resiliency planning has to consider these potential hazards, assessing their effects, potential mitigation strategies, and associated costs. This is true whether one is assessing an individual facility, a campus, infrastructure such as utilities, a service like healthcare, or the impact on communications, data, and or the financial systems. Since secure and operational facilities are critical to the majority of threats, designers and commissioning providers are tasked to consider all aspects when planning, designing, equipping, and testing facilities and their systems. Depending upon the perceived nature and level of the hazard or threat, several questions need to be posed. How critical is this facility, and what duration of outage could it accommodate? What type or level of resiliency should be considered? What level of utility and or system redundancy may be required? Also, what are the potential repercussions? Economic loss, loss of reputation or business, or even loss of life? This chart reflects a number of primary hazards, along with the multiple effects associated with same, as you can see across the top. Irrespective of the primary event, one can easily see that there's numerous effects to be considered, and thus addressed in resiliency planning and risk mitigation. They cover a broad gamut from physical destruction to utility interruption, environmental damage to economic disruption, data destruction to disease. Identifying and assessing these effects or risk is a critical part of any company's emergency program. Let's briefly look at some specific incidents over the past few years. Currently, the entire nation, but especially the healthcare industry, is dealing with COVID-19. Before that, we had SARS, H1N1, Ebola, and AIDS. In early March of this year, Nashville experienced devastating tornadoes, with similar ones hitting Mississippi and Georgia last week, and even last night in Texas and Oklahoma. California deals with wildfires every year, including the notorious 2018 Camp wildfire. We understand that in today's political environment, with various religious and ethnic tensions, there exists a climate for terror attacks. While we often hear of cyber attacks, numerous utility companies continue to report they have annual increases in their attacks on their control and SCADA systems. And finally, the Amtrak derailment in 2017, where a train was traveling at 80 miles per hour around a 30-mile-per-hour curve, reflected that even with supposed fail-safe mechanisms, there could still be tragic accidents, often causing human lives. In comparing the definitions of resiliency and commissioning, we see that proper resiliency planning needs to address the ability to adapt to changing conditions, withstand disruptive events, recover rapidly, and anticipate various interruptions and disruptions. The commissioning provider needs to assist in the identification and planning for facilities and systems to meet these requirements. These need to be documented in the owner's or user's current facility requirements, a real critical document required as part of the commissioning process. However, most importantly, the commissioning provider needs to lead the development of the resiliency verification protocols, operating scenarios, tests, etc. Part of the planning we have been discussing involves a discussion with the owner and the entire project team asking what ifs. Define the anticipated use of a facility during an emergency. Is the entire facility critical or only a portion therein? What's the accepted level of disruption to the interruption of power, environmental systems, communications, occupancy? What's the required level of redundancy? And what's the cost associated with same? Architect and engineer teams have an important role to play, both during planning and then through design. They need to assess the effects of natural weather events in locating and structurally reinforcing the various facilities. Engineers also need to assess the impact of the loss of power and thus indoor environmental systems, or selective interruptions or failures like the loss of a control system. This wheel provides an excellent review of the process of resiliency analysis. Developed by Sandia Labs, it reflects the process I've been describing in identifying, defining, assessing, and evaluating the various risks in determining the required level of resiliency. It discusses the collection of data and the development of models. In essence, it requires a team to learn and adapt, thus developing the metrics to be used in evaluating resiliency going forward. Resilience rating systems, whether performance-based or strategic, really have four major components, as you see listed here. Preparedness, awareness of the risk through identification and the planning associated with addressing same. Mitigation measures, these could be either active or passive, dealing with location, materials, system selection, etc. Response capabilities, on-site and off-site. Does one relocate to another facility or location, or plan to bring in a portable generator or fuel? And then finally, recovery mechanisms. Many utilities have developed restoration agreements whereby they share resources, materials, crews, etc. in times of severe events. And then finally, what is the required recovery time?
So GBCI offers 4 resilience rating system in addition to the LEED system, which we're all familiar with. GBCI also administers the RELY program, which is at the building level, the SITES program, which is at the ecosystems and environmental level, and the PEER system, which deals with power supplies and utilities. In addition, LEED also covers the cities and communities aspects. And you can see that all these programs offer a similar certified silver, gold, platinum rating system that we're familiar with on the LEED protocols. The RELY was developed to elevate the importance of resilient design in communities and building structure. RELY can help identify and reduce the risk of damage to projects in the event that natural disasters or other crises occurs. RELY assumes local or national response within approximately 4 days. The use of durable materials, rainwater collections, 8 categories with 50 requirements comprise the RELY metrics. Bundling sustainability and regenerative guidelines, including many of the credits drawn from LEED, is a strategy for completing the RELY program. Emergency preparedness, adaptation, and community vitality are part of the comprehensive rating system for the socially and environmentally resilient design and construction. If we look at sustainable sites, their reference guide is available online. It's about $219, and it really is about the most comprehensive system out there for rating sustainability as far as resilient land development is concerned. It's about protecting and enhancing the benefits for functioning landscapes. And the overall goal is to benefit the environment. The PEER program deals with power supply and the ability to have resilient consumer metrics with the power supply. There's a power performance rating system, and basically they use a consumer-centric, data market-driven for cities and utilities, campuses, and transit projects. They also have a guideline online. I think it's $269. And if you look at their scorecard, and this is similar for the other 3, they look a lot like LEED. And of course, it's developed by the same organization, GBCI. So I guess that's not entirely surprising as far as that goes. If we look at the normal LEED version 4 program, we can find that there are really 3 resilient design pilot credits now available. That's 99, 98, and 100. And what we're talking about is assessing, planning, and resilience. We're talking about design enhanced resilience and passive survivability. So basically, there are also 2 policy briefs that you can access from LEED. One is how LEED empowers projects to achieve a higher level of resilience, and the other one talks about profiles of resilience and LEED in practice and gives several very interesting examples as far as the LEED process is concerned. GBCI resilience rating systems include the regular LEED version 4 and LEED version 4.1, and you can see that in addition to the LEED climate resilience screening tool that you can also find at USGBC, all of these unknown categories between site assessments, land protection, life cycle impact, these all are directly related to resilience and reliability in systems. There's a great deal of educational information also available at USGBC, And all these are very recommendable webinars, courses that you can take to really learn a lot about methodology for achieving resilience under different types of circumstances and for different systems. I'm going to diverge for a second, but I don't think it's so much of a divergence because it's actually part of, you know, what we're living through right now. And it's the idea that one word defined tech firms in the last couple decades, firms such as Facebook and Google and Amazon, things that we well know. And these use business to consumer or consumer to consumer platforms that rely on the internet. They connect producers and deliverers with consumers, but their main business is to collect and analyze mass quantities of data. These firms are the first great industrial platforms, platform being the word that really defined these companies. And you say, what does that have to do with the current COVID situation? There was a great article in the Wall Street Journal this week. It was called Made in China Censorship for Sale, and it talked about content moderation systems, which are platforms that I'm talking about. And for example, you can get into the internet in China, and the name of their leader is not allowed to be used unless it is government approved. So they scrub Xi from almost all internet traffic in China. Compare that to the United States, where comedians can hold severed heads of our president on TV. What is an industrial platforms? These are software tools and internet communication tools that wield power over communication. It's being done with very little historical precedent and in a hands-off regulatory environment. These platforms prioritize adding suppliers and consumers over quality, and they seek to disrupt traditional business methods. Platforms are not media sellers, service providers, or operators. They are mass data collecting and analyzing organizations. The tech firms grew very quickly, and it's pretty much agreed across the board that more regulation is needed of these platforms. The 1996 law, which was brought about way before we even understood what the internet was, and 4 years before Amazon, that no provider or user of an interactive computer service shall be treated as the publisher or speaker of any information provided by another content provider. In other words, the government was giving broad immunity to companies that were developing these internet platforms. Of course, this resulted in a social backlash, and in 2016, we saw this come to the head with the presidential election and a lot of the disinformation that was alleged on the various platforms that I mentioned earlier. Amazon has also seen backlash in terms of counterfeit and unsafe mitigation costs. In 2018, Congress removed the immunity for online sex facilitation, and companies such as Disney and NBC actually protested this because it was the beginning of the removal of Section 230 protections. In 2019, Airbnb and Expedia Group were required to follow city rules in California, and this year Uber and Lyft were required to make their drivers actual employees. So this is why you're seeing Amazon and some of these other companies invest in brick and mortar stores instead of their traditional platforms, because they are seeing their protections removed, and they are recognizing that moving forward, industrial platforms are going to be in the hands of government. Business-to-business platforms are also being developed, and Google and Amazon are actually two of the biggest, or Google and Amazon are the two of the biggest people trying to compete for the business-to-business market. In the future, we'll have small business platforms, we'll have business platforms for individuals, so the market is changing. I think a really good example of the impact of industrial platforms are the earthquake and tsunami that occurred in 2011 on Kyushu Island. And we saw that the nuclear power plant meltdown and huge economic disruption. Two of the big factors were underreacting, plant shutdowns and transportation bottlenecks that weren't necessary, and overreacting, panic hoarding, such as we experience now with toilet paper. But in 2016, a similar earthquake, and a country that used the Jabil control platform was able to identify alternate suppliers. Even though they lost power, they were able to proceed without disruption because they had the resilience of industrial platform to help them move through their problems and solve them quickly.
Obviously, the COVID-19 pandemic has dominated the news for the past 60 days, resulting in what many consider the greatest healthcare crisis since the Spanish flu and the greatest interruption to economic activity and societal life. While we monitor the news and the number of cases, we hear questions regarding lack of preparedness. Where were the stockpiles of masks and ventilators? How has this disrupted the supply chain, and what could have been done to anticipate this? The federal and state governments have appointed task force to address logistics, but they're operating in a reactive mode. Where was the proactive planning? We've been issued new rules under which to live and work. However, these have evolved over the last several weeks. Often, states' orders have varied, instituted and/or extended on different dates, but based upon what? Evolving information fed from what appears to be defective models and questionable data from countries around the world. Again, where was the upfront planning? Was a complete quarantine lockdown required for everyone? These are the questions that continue to be asked, and it appears to show a lack of resiliency, a lack of planning. There's a lot of information available now, but not all of it seems to be consistent. Look at this chart from WebMD. It states that the virus can live on metal surfaces for up to 5 days, but we've seen ranges anywhere from 3 to 7 days. We know that there's many stainless steel tables and equipment in healthcare is being disinfected on a continuous basis. The chart also says that it doesn't seem to spread through food or in water, but what happens with respect to individuals touching packaging or produce at grocery stores? Again, a number of questions, and there's still people out there trying to answer some of these. This graphic represents the recommendation for social distancing. While some virus particles would fall within a distance of approximately 1 meter or 3 feet without any accompanying airstreams, they could be carried in an aerosol fashion for several feet, eventually breathed in by surrounding personnel. The lower right graphic reflects the configuration of a virus cell with the spikes contributing to the name corona, very similar to the flu or common cold. The lower left and center photos are electron microscope photos of the virus from CDC.
Of course, Bob is showing the germ that we're trying to protect people from. One of the big tools in healthcare facilities is the 3M N95 mask, but an issue that has really arisen in the shortages and the lack of previous stockpiling is the alarming number of counterfeit masks on the market. One thing is that these masks have authenticity numbers, and it's very important that hospitals have databases and the ability to use software to interconnect with the supply chain so that they can verify authenticity numbers. This issue got even more complicated when the federal government reversed its decision due to supply shortages and are now allowing the KN95 masks from China, which have even a larger set of counterfeit complexities and a greater need to look at not only authenticity numbers in the United States, but also across the world. And this is why industrial platforms are crucial in helping to solve these problems. Stockpile allocation systems have been turned on the end with this issue. And for example, in the state of Kentucky, we've had to migrate to the Web EOC software in order to keep up with the demands of allocating resources effectively. There's been a lot of ingenuity associated with the COVID case and a lot of hard work by engineers. In Johns Hopkins, they developed 3D printed splitters in case that ventilators needed to be shared between patients, which it hasn't really come to. In the early days of this COVID-19 crisis, Smith Seckman Reed, an ACG member, put a one-page checklist into the hands of hospitals in Kentucky and other states that really helped them to assess their medical air system, because it's one thing to buy ventilators or to supply ventilators. It's another thing to have the medical air systems on your head wall that can support them. Surge planning is extremely important when you talk about medical gas systems and ventilators. Do you have the fittings on hand to accommodate new equipment? Do you have the bulk oxygen supply zones understood to where you can pick zones closer to the supply with the largest pipe sizes and the shortest pipe runs? Each ventilator has its own continuous flow requirements and lowest operating pressures. And this is incredibly important to know so that you don't overtax your system. Mainline pressures are normally set at a 55 PSI max, but with added ventilators, we've had to work at the max, which causes a lot of nuisance alarms. And so alarms are recommended to be set 20% high at about 66 PSIG in order to prevent so many of these nuisance alarms. You need to do hour-by-hour monitoring of these medical gas systems because the vaporizers can freeze when they're really running a lot of volume, and you might have to put fans outdoors in order to try to get some of that icing off of your equipment. Bulk oxygen tank capacitor, evaporator capacity could really be the weak link. Filters are another issue. I think the number one thing to understand is air exchange rates are the greatest HVAC tool in order to prevent infection. And that's basically 6 to 12 air changes per hour to be effective. The filters that we see typically in hospital are a combination of MERV 7, MERV 14, but you can see from the slide that the 0.06 to 0.14 micron spherical virions of COVID-19 virus are way smaller than the 12 and then 0.5 micron filtration. Even if you go to 99% or 99.999% filters, some of the particles get through. Fortunately, the viruses are suspended in mucus, and it catches about 90% of the problem, but that still leaves 10%. So you have to use strategies. One of the things is that we're needing more isolation rooms, and so we're bringing in air cleaning machines with HEPA filters so that we're not discharging virus-laden air directly into the atmosphere. Wait time schedules for room turnover are extremely important. If you look at the table on the left, the number of air changes and how long it takes given the filtration is a critical issue regarding hospital turnovers of rooms. There are a lot of resources out there. This is a list, and when the slides get published, you'll have access to it too. But through the KSHE and other associations, we've been really looking at all these different resources to try to support our clients in not only the healthcare, but also pharmaceutical and data center industries.
You know, the American Society of Heating, Refrigeration, and Air Conditioning Engineers, ASHRAE, created a site with a variety of resources for COVID-19. These include the interim guidance from the CDC, guidance from the World Health Organization, and lists of various ASHRAE standards, guidelines, articles of position documents. In addition, ASHRAE has established an epidemic task force to help deploy ASHRAE's technical resources to address the challenges of the current pandemic and any future epidemics as it relates to the effects of HVAC systems on disease transmissions. The website address for this information is shown at the bottom of this slide. Some of the initial guidance from ASHRAE is listed here. While HVAC systems have typically played a smaller role in infectious disease transmission, Jim just noted the small size of this virus with respect to filtration. The role of the HVAC systems is really part of what ASHRAE's Epidemic Task Force is reviewing further. Their current recommendations include disabling demand control ventilation and increasing outdoor air ventilation within the constraints of temperature control and ambient air pollution. Additional recommendations include sealing the edge of filter racks and the upgrade of filtration. They also recommend operating HVAC systems 24/7 and considering the use of UV lights coupled with filtration. The pandemic has also brought changes to the construction environment, and various contractors are enhancing their safety plans. They're eliminating meetings in trailers. They're installing additional hand sanitizer stations. And again, they're abiding by the recommended social distancing between subcontractors, and many of them are limiting visitors to their sites. Architects, engineers, commissioning providers, and even building inspectors are conducting their meetings via video teleconferencing, and they're really examining new ways to respond to issues from the field and to inspect sites through either pictures or video. The cloud has really become more critical, with remote employees relying on it and the internet for collaboration, and home-based individuals increasing their use of online commerce. The Uptime Institute is really the leader in the IT industry's development of global standards for the proper design, construction, and operation of data centers and related mission-critical facilities. Always conscious of the need for reliability and resiliency in these facilities, they were one of the first to issue recommendations to their industry with respect to COVID-19. These included the development of facility pandemic preparedness plans, along with incorporating related strategies dealing with epidemics into their emergency operation procedures. Understanding the critical nature, I should say, of communication and data access for all mission critical facilities, including both healthcare and first responding agencies, the Uptime Institute recommends that its members test their networks to confirm the higher volume expected with numerous personnel working remotely and connecting through VPNs. They also recommend any unnecessary maintenance or construction projects be temporarily postponed to avoid potential interruptions of service. One of the issues that appears to make data centers a little bit more vulnerable rests with the average age of the operating workforce, which in many cases exceeds 50 years of age. In discussing resiliency metrics, the Uptime Institute, quite a while back, developed a series of 4 tier levels to rank data centers based upon their reliability and resiliency. These examine potential single points of failure, annual downtime caused by the site, and thus the representative site availability. As you can see here on this chart, Tier 3 has a site availability of about 99.98%, while Tier 4, its highest level, has a site availability of 99.99%. Similarly, the Uptime Institute has developed a 5-category rating for the severity of service outages, rating them from negligible to severe based upon a number of factors, including financial effect, losses, reputation concerns, safety issues, and losses of customer data. Naturally, these disruptions have numerous consequences related to healthcare information, first responder information, and most importantly, online commerce. More specifically, to reflect the economic numbers, Amazon Web Services had several outages in their Virginia data centers back in 2018 between March and June, including approximately a 6-hour outage during their annual Amazon Prime event. With the increase in number, size, and complexity of new data centers, many serving the cloud, the number and average duration of outages has been increasing annually. Last year, the average cost of a data center incident was about $750,000, or roughly $11,000 per minute. The maximum outage cost could be millions of dollars. This has only increased during this pandemic, when I hear recently that Amazon revenue numbers are in the range of $11,000 to $15,000 per second.
Another important aspect of our society is the cold chain. We need to avoid food spoilage and, protect the food supply of our country. Resilience plays an important role in this, and this is also an area where we can see that resilience can be combined with normal operation. So it's not just a matter of outage, but it's also a matter of stability of your operating system. We want to maintain the security of the food system from loss of power, from equipment malfunctions, which could include things like compressors, condensers, fans, pumps, electrical devices, and controls. Also natural disasters. One of the big developments, and it has a lot to do with material property development, is the advent of thermal energy storage, which improves efficiency, minimizes fluctuation, and extends protection. It's an example of providing resilience and also saving energy. There are 3 real strategies used in the cold chain for thermal energy storage. One is backup cooling for power outages. Another one is cooling during equipment failures. And the third one is supplemental cooling during high ambient temperatures. Backup cooling during a power outage could be as simple as connecting a thermal energy storage system to a generator or a battery to power your pumps, to buy time for replacement parts to be in repairs, or to get a truck there to refrigerate your goods. Another power outage scenario would be combining a thermal energy storage system with a generator or battery to power your cases and your walk-in freezers. Stability is the key in this industry because frozen food is affected by fluctuations in the temperature of the food that causes microthawing of the freezing particles, and those large ice crystals degrade the food, which is obviously not desired. Thermal energy storage systems use latent heat, and they absorb 50 to 85% efficient. They consolidate heat near the top of a room where the refrigeration airflow occurs. There's a shift. There's other strategies that we can use in the cold chain too, which is the shift night compressor runtime. 25% less energy and improved temperature stabilities are known from applying thermal energy storage systems. We can combine this with phase change materials, intelligent controls, and load shifting and demand response to both provide a resilient, reliable, and normal operations. And I should point out too that the cold chain is crucial in maintaining our medical supplies. And for example, vaccines typically have to be refrigerated. So resilience and reliability in the cold chain is extremely important. When Bob and I conceived this presentation last year, my motivation was the Boeing 737 MAX. And we saw the crashes that occurred that caused a lot of loss of human life. In fact, a total of 346 died in 2 crashes. There was the Lion Air crash over the Java Sea in 2018, and the Indonesian investigation attributed the accident to design flaws, that a single angle of attack sensor reporting erroneous data shoved the nose downward and caused a 21-degree misalignment that contributed to the death. This was done at a maintenance operation prior to that flight, and it reflected inadequate training, maintenance lapses, and the investigators said that there were 9 critical problems, any one of which could have prevented the tragedy that happened. In March of 2019, this came to a head when a second plane crashed in the same way. That was the Ethiopian airliner that killed 157 people. The Ethiopian interim investigation report again cited design flaws. They noted the unstable adjustable stabilizer and that the controlling software had flaws in it, and that those flaws were not relayed to the operations people, and they were admitted in the O&M manuals. The rollout of controls to solve a mechanical problem in an aircraft provided a very single solution with no real resilience that led to tragedy. And the U.S. Committee on Transportation and Infrastructure cited that production pressures, a culture of concealment, and safety certification process irregularities were direct contributors to these tragedies. Moving to a more pleasant subject, the community-based resiliency at Alice Beach. There is a home program called Fortified that is considered the national standard for resilient construction, and it deals with homes in the coastal regions that are affected by rising sea levels and floods and so forth. The key is that there are first and second order environmental disaster impacts. First order are the obvious loss of life, displacement of people that comes from the immediate after effect, and then the need for construction. But the second order impacts are also life-threatening in the sense that they shut down the social systems and they can make it hard to get the healthcare providers where they need to go. It can close down businesses and devastate infrastructure. So this program tries to use front-end site-specific information to develop good plotting and siting of buildings. And it wants building structures to be resilient in terms of being able to absorb wind and seismic and flooding forces. So things that contribute to fortified built communities are deep piling foundations and flood walls that can resist 100-year waves. Gulf-front properties are platted in the Alice Beach so that the buildable surfaces are landward and the beach line is protected. There's actually a protective zone that's defined, and the development preserves the inland waterways to their historic flood paths, which reduces flooding caused by a lot of development in other places. Master planning maximizes the green spaces and the use of permeable concrete, and requiring town architects and review boards to review proposed construction is a big part of the Fortified program. You can see a couple of the standards that are used there for defining flood resistant and residential construction for coastal zones. Another thing that it comes to light in this is severe duty louvers to improve resilience. And you think of this in terms of hurricane prone areas like Florida, for example, or anywhere on the coastlines of the country. These are heavy duty louvers that can resist high wind forces. They can also withstand hard subjects like missiles hitting them, you know, big objects like bricks or pieces of wood and things like that. And severe duty louvers also need to be considered in areas that aren't necessarily coastal areas. We had a project in Western Kentucky in the middle of the state where after turning the building over, we were called back because there was ductwork collapse. And of course, the assumption was that, you know, a failure of the commissioning process led to a shut damper. And we went and retested and everything was working perfectly. And what we discovered was we had a minimum outside air intake on one corner of the building, and at a 90-degree angle was the main outside air intake. And when we were economizing with the unit, a storm came, and that storm caused a pressure differential on the corner, and it imploded the entire ductwork for the return air system. So this is a good example of considering resilience ahead of time when you know you're in an area that is susceptible to high storms and winds and so forth.
Getting back to facilities in general and speaking about ASHRAE, they've taken a very proactive approach to resiliency in the design of their new global headquarters. A number of the potential resilient measures were identified during the development of the project's owner's project requirements or their current facility requirements. And as they were developed, they were ranked as either low, moderate, or high with respect to cost. A number of these features are listed here, including passive survivability in the case of a power outage to the environmental systems, standby generator, battery backup systems, impact-resistant windows, backup communications, and even redundant water supplies. Again, the proactive approach for resiliency up front in the planning of this facility. Part of the focus on energy resilience also deals with combined heat and power, or CHP systems, and associated renewable energy systems. As everyone has seen through the global moves towards sustainability, the utility industry is starting to move to a distributed, low carbon, resilient model. And this decarbonization and the need for resilience helps drive the adoption of CHP systems. CHP and various renewable energy systems such as solar photovoltaic, wind turbines, etc., can be integrated together, but also present challenges in maintaining a stable grid. In addition, when sizing and designing CHP systems, it's very important to properly evaluate the anticipated thermal load. As previously discussed, healthcare facilities, especially hospitals, have a high need for reliable and resilient power. These are especially good candidates for CHP and fuel cell systems, both systems which provide both electric and thermal energy. CHP, fuel cell, and even renewable energy systems, which operate year-round, are viewed as more reliable than standby generators, which may only be exercised periodically and only run during periods of emergency. Fuel cells convert chemical energy from hydrogen-rich fuels to electric power and heat. These can both use natural gas or clean renewable biogas. And really, both of these systems are seen as reducing emissions and enhancing environmental sustainability.
Retrofits should also be considered in terms of resilience. These facts are very critical at this time, and I know our leaders, both at the state and federal level, are aware of the fact that 40 to 60% of small businesses never reopen following disasters. That's a devastating statistic, as is the fact that 90% of small businesses fail within 1 year if they don't reopen within 5 days after a disaster. Keeping buildings open is a prime resilience strategy to spur bounce back of the economy and the social structures in communities. And retrofits can address energy efficiency and resilience as co-benefits, as I mentioned in connection with the cold chain discussion. A good code, of course, is the International Energy Conservation Code. On-site electrical generators, CHP, as Bob mentioned, photovoltaic, all these types of systems can be added in retrofit renovation projects to increase resilience. So we need to reduce complete reliance on the energy grid and figure out how we can accomplish passive survivability. If a facility is undergoing a power change. Can we maintain thermal comfort, lighting, communications, water, and sewer? We prioritize life safety, and we maybe maintain the ranges a little wider, but what can be done when you're doing renovation projects? Strategies to mitigate heat gain or loss in the building, something as simple as adding insulation. In New York City, when a high rise goes down in the middle of summer, it's been documented that they can get to 120 degrees within something like 3 hours in the middle of a day. So sealing leaks and penetrations, reducing air leakage, providing operable windows with HVAC interlocks, and doing daylighting and avoidance of light blocking in renovations are all critical strategies to the survivability and the resilience of our built infrastructure. In terms of the bad example, PG&E wired to fail in California. Bob already mentioned the Camp Fire that was devastating. That was only one of 4 PG&E sparked fires that day. The 408th fire that PG&E power line sparked that year. But you know, the Camp Fire deaths are not all on PG&E, and neither are all the fires. There's plenty of development issues that led to trouble. The 1,961 wildfires sparked by PG&E since 2014 attest to the fact of the 15 years of bankruptcies have caused deferred maintenance on their electric lines and their gas pipelines. We saw the 2010 San Bruno explosion of a gas pipeline that killed 8 people and injured dozens, destroyed 38 homes, and it was the result of an uninspected 1956 weld. Also, the government imposing green energy mandates on the electrical utility company and raising them from 10% to 33%, that just resulted in deferred maintenance on their infrastructure, which led to some of these exasperating tragedies. The old saying for PG&E, their motto was, PG&E is committed to protecting our customers and privacy. You can look on their sites now and you'll find out that that's changed. They're now committed to protecting their customers' safety. Outsourcing of pipelines and leak detection and damage control were the leading cause of violations from regulators for PG&E. They also did a 2006 business transformation software overhaul that lost work orders. So, you know, there's a lot of issues. The grid improvement costs in California alone are in the hundreds of millions of dollars. And those deferred costs resulted in $13.5 billion of settlements due to tragedies of people. In 2009, California regulators were asked to, provide relief to PG&E to pass costs on to consumers. It took a decade, and California Proposition 16 failed. Reliability statistics also were a contributor to some of these shortages because they had installed new automatic restart technology on a lot of their old power lines. So the reliability statistics that they focused on to concentrate urban and suburban priority were really false in the fact that they were having a lot more failures. They were just resetting those failures quicker. And to compound things, in 2018, shortly before leaving office, the governor of California reset the target for renewable energy to 60% by 2030. It's not a bad concept, but the idea of the cost in terms of deferred maintenance and potential tragic loss of life due to lack of resilience also need to be taken into account. Another single-minded thing was the 5G rollout. The idea that, the Sprint and T-Mobile merger really focused the fact that the market was betting on a fast 5G rollout. Samsung put out 3 phones, and Apple's going to have their first 5G phone in the fall of this year. So carriers have to build out these 5G systems sufficiently in order to attract more customers, and they're starting to see a lot of pushback right now. South Korea was the first 5G deployed market, and now their consumers are complaining of the fact that they're not getting the reliability and the speeds that they were wanting, because proximity is the key to 5G availability, and the build out is just not matching the demand for these services. More base stations and relays and antennas than traditional infrastructure will result in massive build outs that tear up cities, and there's a lot of pushback both in Korea as well as in the United States. So Ericsson reported that higher 5G related costs are causing slowdowns in North America and Asia. An interesting connection here too is that South Korea is one of the most effective countries at combating the COVID virus. And one of the ways they did that was their 5G build out was complete enough to where they could install infrared sensors and really detect temperatures of people in public and isolate them quicker than a lot of other countries do. Of course, we're talking about that and using drones in this country, but of course we also have privacy issues and other issues to concern with that.
You know, energy resiliency is important for all federal agencies, but especially those associated with Homeland Security and the Department of Defense. As stated here on this slide, the homeland is no longer a sanctuary. The National Defense Strategy has three main goals: energy resilience, security, and cost savings. Various initiatives underway include energy resilience through microgrids and standby power, hardening controls and data from any cyber attacks, and assessing and protecting physical assets. Various executive orders and mandates require agencies to increase their percentage of renewable energy, reduce their energy consumption, and thus reduce their greenhouse gas emissions. Various military service agencies, including the Army, have been especially aggressive in ensuring they meet their energy resilience goals. The Army is especially sensitive to mitigating any disruptions to their electric, water, and/or fuel supplies. With respect to energy, many bases have established microgrids, self-sufficient and capable, serving their discrete footprints, the base or whatever, in an island fashion upon the loss of utility power. Again, one or more types of distributed energy, solar PV, wind turbines, combined heat and power, and/or even generators may be employed in these microgrids. As battery technologies advance, some systems are employing energy storage as well. The military views security and resiliency as critical components of system readiness. Multi-domain operations are directly related to multi-domain management of resources. The Army's intent is to be able to maintain critical missions for at least 14 days in the event of any utility disruption. As noted above, they no longer view the homeland as a sanctuary, and the 156 Army installations and their associated National Guard and Army Reserve Centers are part of the domestic battlefield. Planning, design, construction, and commissioning of these systems are absolutely critical to verify they meet the criteria established by the Pentagon. Equally important is the resiliency of our international facilities around the world. The Bureau of Overseas Building Operations, part of the U.S. Department of State, oversees embassies and consulates throughout the world. Based in a wide variety of foreign countries, many of which have varying instabilities, political, security, utilities, etc., these facilities must be designed for a measure of self-sufficiency in times of trouble. While physical security is of paramount importance, considerations must also be given to all infrastructure services.
So that brings us to the resiliency conclusions that we have for our presentation today. And it is really a new normal. We're no longer about what outage or how long, but how disruptive and costly, and what is our strategy in place to deal with it. Commissioning enhances resiliency by making sure systems work, by checking backup systems and understanding how things interconnect and integrate with each other. I think commissioning is in itself a resiliency tool. Forward-thinking groups can leverage resiliency planning as a strategic asset that the commissioning providers incorporate into commissioning marketing. Government agencies, institutions, commercial business are all developing resiliency plan. The Army that Bob mentioned and the multi-domain operations, where traditionally we had land and maritime, but more and more air came into it. But nowadays we also have space and cyber realms to deal with. So there's a great deal of planning that needs to go into all of our different industries that we deal with. Architects and engineers, commissioning providers, energy managers, we can all contribute to resiliency planning, design and commissioning, and understanding the effects of various hazards, and their proper mitigation. Bob, do you want to add anything to the conclusions?
No, I think that's it. That kind of sums it up. And I'm hoping that everybody today got a feel and a flavor for, again, the importance of resiliency, reliability, both with building systems and even with various services, so on and so forth. So I really appreciate everyone's attendance today. And do you have any final comments, Jim?
Well, I think we can go through some of the questions since we have a few minutes left. And I think one of the first questions that I saw was questioning about the cold chain and what type of thermal energy storage systems are being used. Really, in the cold chain, we see two types. One are permanently installed systems that, as I mentioned, tend to bring reliability and energy efficiency along with the resiliency capabilities. Also good for high heat loads and so forth. These systems are typically molten salt heat transfer mediums. That's the technology. There's companies that I know of out there, you can find them online, that market various types of systems, whether they're permanent or whether they're temporary systems that are kept on hand or brought in the case of emergencies. But typically the new materials are the molten salt machines. Bob, we have another question. Where does commissioning responsibility for resiliency begin? Planning and design responsibilities been left to the design team. So should commissioning suggest these issues be addressed in the owner project requirements? Of course, once the strategies are chosen, designed, and constructed, the commissioning authority needs to ensure their proper functioning.
I guess what I would say, Jim, is yes, absolutely, that it needs to be thought of and included in the owner's project requirements. If you think back about that slide that I showed for the ASHRAE Global Headquarters, there was a specific requirement within there to talk about during the development of their OPR about resiliency, and they actually had a number of various ideas that they brought up and ranked as either low, moderate, or high in cost. And then they went about making selections, again, based upon their priorities and their budget, But I think when you talk about the upfront planning and design responsibility, yeah, I would say that the architect and the engineer typically take the lead. But again, when you look at the commissioning process, the commissioning provider is part of that process, and he should be engaged early on, and he should help to develop and to really vet a lot of these project requirements. So I think he has a responsibility up front to help with that development and to make sure that it's included as part of developing, whether it's a new project or even current facility requirements, if it's being a retrofit project like we talked about.
We have another comment too, that resiliency is an important topic. They said that our presentation suggests that the commissioning provider take the lead role in resiliency criteria development and mitigation. This seems an overstatement of the CXP's role. Resiliency is a topic in the OPR, and the CXP should confirm it and any systems that come out of it. It seems a design team or a special consultant should lead to resiliency. I agree with that in general. I don't think Bob was indicating that the commissioning authority or the commissioning provider was the lead in it. I think it's just that, as with all issues, we have to facilitate responses and work with a team approach. Obviously, the final liability for the system is going to always reside with the design authority. You want to comment on that, Bob?
No, I agree with you, Jim, and that is what I was trying to say, is that the commissioning provider is really part of the team. He is not necessarily the lead, but he's part of the team, and I think he should participate when they have, an open roundtable, when they go through and ferret out these various requirements up front.
So I have another question. If for buildings, if there is emerging insurance or other data to assign value to avoiding extended shutdowns, it'd be nice to have some tools to quantify this value, like value added from commissioning in terms of operating costs. And I think this is a place where ACG can really move the industry forward. I think we need to get involved with underwriters, bring them into our meetings and webinars, and have these conversations. I have always advocated for the fact that commissioning should lower the insurance cost on projects as a standard of doing business. And I think that's more important when you're looking at emergency planning. And I do believe that you can work towards insurance benefits, and that we as an industry and as an association need to work with the Underwriters Association. I've had several meetings through the years, either for ACG or for the BCA, where we have brought in insurance companies and brought conversation about this very issue. So I think it's a point well made and something we should follow up. Another question is about whether there are health risks with the 5G transmission. I think the jury's out on that. I think there was a lot of this type of concern when cell phones were first brought in, whether they bring brain cancer or stuff, but certainly increasing proximity and signal strength and energy of waves. There's a lot of technology that's being developed, like wave formation and other things that really are going to require a lot of research moving forward. And I think there's basically unknowns. With that, Bob, thank you. And thank you, ACG and friends. And Ray, do you have any closing remarks?
I just want to close things out by saying thanks very much to Jim, you, and Bob for sharing your expertise. And to everybody on behalf of ACG, EMA, and AABC, thank you very much for attending this first CxEnergy virtual webinar. We hope that most, if not all of you, are joining us for the next 7 Thursdays for all the variety of additional presentations we'll be offering. Keep your eye out again for an email with information about how to get your CEUs through the CxEnergy app. And thanks again to all of you. Many of you on the call are members of our various associations, and thanks to all of you for being members and for attending. Everyone, please stay safe and continue to be resilient in the face of all this. Thank you.